Hello friends, welcome to my channel Vartita Learning Platform, and on this channel, as you know, that we are studying about the NumPy libraries. So the NumPy libraries are used by the data scientists, those programmers who are working on the machine learning things. So NumPy is a very useful library, and when we talk about the NumPy library, then in that library there are certain functions, functions exposed for creating the probability distributions. To understand the probability distribution and to utilize them, we must need to know about their concepts, right? What is the probability, what is their distribution, what is the probability distribution means, why we need that probability distribution. All those things are very much needed before you dive into these things and use those formulas, use those functions, because without knowing how will you use a particular distribution function for your machine learning model, you should be aware that in this case the probability distribution, this should be the probability distribution and this formula should be utilized. This is the particular scenario and this particular distribution fits in here, right? So we must need to know about the probability, the distribution, the calculus as well, the integration and differentiation as well, right? But yeah, I'm not going to explain that much detail, but yeah, there will be a separate playlist, and these videos will be the part of that playlist, and you can see here. So in these videos you will be able to find out that what is the basic thing related to the probability distribution, what is probability, and basically all those things related to which all the functions have been provided in the NumPy library. So this is one of the topics which we must need to understand for the NumPy library and the distribution functions. So we are going to discuss about the probability today in this particular video, and this probability we are going to discuss about the three things. First thing is the probability itself, what is the probability. Second thing is the probability random experiments. What are the random experiments? What is the meaning of being random, doing the random experiments? And then we will see that what is the probability distribution curve, why we call it as a probability distribution curve, and what is the meaning of that curve, and what is the what is the area of that curve depicts, right? So that is what we are going to do. And the basic prerequisite is that I assume that you know a bit about the integration, right? And you know a bit about the probability, although I'm going to explain basic things about the probability, but yeah, I would expect that yes, at least the integration, at least those things are clear from your school days or college days learning, right? So let me start this one. So first thing we are going to discuss about the probability. What is a probability? Probability is nothing but for some event, the chances of some event to happen, right? For example, if I have a die and the die has 6 faces, when you throw a die, then you can get 1, you can get 2, you can get 3, you can get 4, you can get 5, and you can get 6. This is the probability that this is the sample space. This is known as the sample space. All the possibilities, the set of all the possibilities is known as the sample space, and we represent that sample space by S. So let me put the sample space. Sample space is, while throwing a die, I can get 1, I can get 2, I can get 3, I can get 4, I can get 5, and I can get 6. So this is known as the sample space. What is the total what is the total number of elements in this sample space? That is represented by NS, which is 6. 6 is the total number of elements in this space. Now we are interested into a certain event, and that event is that I should be able to get 1. When I throw a die, then I should be able to get 1. Then what will be my event space? Similarly, the sample space, similarly we have to create the event space. So what will be my event space? In the event space there will be only one element, that is 1, the one which we want, right? So that is 1. So this is the event space. And how many elements are there in the event space? These are 1 only. This is 1 only, right? So when you try to find out the probability, the formula is probability of event is NE upon NS. So it becomes 1 by 6. So finding 1 after throwing a die, the possibility is 1 by 6. The probability is 1 by 6. So this is how you calculate the probability, right? Similarly, if you throw a coin, then the coin has 2 faces. One is head and one is tail. So if you try to find out the probability of getting a head, then what will be the probability? Probability will be 0.5, or you can say 1 by 2. Right? So this is how the probability is calculated. number of elements in the sample space and the number of elements in the event space. Event space means what is my expectation, what I want, right? What I want to get, right? I want to get 1, right? Similarly, if someone says that I want to get an odd number, whenever I throw a die, I should be able to get an odd number, right? So in that case, sample space is here, all the possibilities 1, 2, 3, 4, 5, 6, and now the event space will contain 1, 3 and 5. These are the odd elements, right? So because these are the odd elements, so I have added all these into the event space, because my expectation or my event is that what I'm interested is that I should get 1 odd number whenever I throw a die, and that odd number can be anything, 1, 3 or 5, anything, right? So if I see this event space, then it becomes like number of elements is 3. So if you calculate the probability, then it becomes like 3 by 6, which is 1 by 2 is equal to 0.5, right? So after all this discussion, you must be taking one inference from all these events, that the probability of getting any probability of having an event can be only between 0 to 1. Maximum 1 can be the probability. 1 means 100%. 0 means nothing. Suppose if I'm throwing a die and if I expect that I should get an odd number, then it may be that some even number comes. Then the 0 will be the, in that case 0 is the case, right? I didn't get, right? But yes, in that case it's 0. For that particular moment it becomes 0, right? But when I go ahead and think about a broader perspective, like that I can get one even odd number, right? I can get one odd number. Then in that case what happens, that I have 3 odd numbers and total 6 numbers. So 3 by 6 is equal to 1 by 2. That I must need to get, right? So that is the probability, 1 by 2. And if someone says that after throwing a die, I should get a number which is greater than 6, right? If this is the event, that after throwing a die I should get a number which is greater than 6, then what is the probability? Probability is 0, because you cannot get any number greater than 6 after throwing a die. So this is 0, right? So the probability of any event can be between 0 till maximum 1, right? And if someone says that, let us discuss about the 1 as well. So if someone says that when I throw a die, I should get a number, I should get any number between 1 to 6, right? Any number between 1 to 6. Then in that case probability will be 1, because after throwing a die, you will get at least one number between 1 to 6, right? So that probability is 1. You need to consider the event. What event says? Event says that when I throw a die, I should be able to get any number between 1 to 6. So you need to take care of the event, the statement of the event, that what the event or expected event we are describing as, right? We are describing the event as that I should be able to get any number between 1 to to 6. Then in that case the probability is obviously 100%. I am getting that, right? So any probability can be between 0 to 1, right? So this is how the this is first thing you must need to understand, and you need to remember this thing. Okay, now we come to the other things, right? Like some certain type of events, right? So let me explain you a few events. One is complementary event. Right? One is complementary event, right? Complementary event means if one event happens, suppose there is one event E1 and there is one event E2. So if event E1 happens, then E2 automatically happens, right? If E1 is happening, then E2 automatically happens. Then in that case, E1 is said to be the complementary of E2, right? And what does that mean? Or you can say this E and E dash are the two complementary events, right? Complementary events are shown like this. So when some event happens, like suppose I'm considering two events. One event is that when I throw a die, I should get an even number, right? I should get an even number. One event is, one event is like I should get 2. For example, I should get 2, right? I should get 2. One event is that I should get 2. So E will be 2, only one element. And the other event I am considering E2, that whenever I will throw a die, I should get an even number. right? Here I am saying that I should be able to get 2, and here I am saying that I should be able to get an even number. So whenever I will get 2, that simply implies that I am getting an even number. Getting my point? If I am getting 2, then it simply implies that I am getting the even number as well, right? So these two events, E and E dash, these two events, E and E1 or E2, E1 or E2, E1 is said to be the complementary of E2, right? E1 is the complementary of E2. In that case, we represent the other event as E dash. If first event I am representing as E, then the second event I am representing as E dash, right? So this is how the complementary events are mentioned. You must need to remember these things. These are not just the definitions to learn by heart. You need to consider these scenarios when you are working with the real life problems, where the events are mutually exclusive, where the events are complementary to each other. So I hope you are clear about this one. If you are not clear, you can let me know in the description section, in the comment section. So after the complementary events, I would like to explain you about the mutually exclusive events. Mutually exclusive events. Mutually exclusive events means if some event happens, if E1 is happening, then E2 is not happening. There are two set of events, two events, right? First event is on throwing a die, I should be able to get an even number. The second event is that on throwing a die, I should be able to get an odd number. So when I will throw a die, then either I will get an even number or I will get an odd number. Both things are not possible. So if I am getting an even number, then I am not getting the odd number. So both these events, which says, one event says that I should be able to get an even number, the other event says that I should be able to get an odd number. So when I will throw a die, either I will get an even number or I will get an odd number. So these two events cannot happen together. One event does not imply other, just unlike the in the complementary event. So the events which are not complementary, and if one event happening means that the other set of events will not happen, then this is known, these kind of events are known as mutually exclusive events. I hope you must be clear about this now. What is the mutually exclusive event? If something happens, then if it implies that the other thing will not happen, then in that case it is known as the mutually exclusive events. Now let's see the definition of exhaustive events, right? The other event is exhaustive, E-X-H-A-U-S-T-I-V-E, exhaustive events. What are the exhaustive events? Suppose I'm throwing a die. The sample space is 1, 2, 3, 4, 5 and 6. These are all the possibilities when I throw a die. Now I'm creating 3 event sets. First event set says that I want to get the odd numbers 2, 4, 6, right? The second event says I should be able to get the numbers below 3, so 1 and 2, okay? And the third thing says I should be able to get, the event 3 says I should be able to get the odd numbers greater than 1. Odd numbers greater than 1, which becomes like 3 and 5, right? So these are the event spaces for 3 different kind of events that we have thought of from this sample space. This is our sample space on throwing a die, all these possible things I can found. And after that I have just created 3 event spaces. First event space says that all the even number I should get. The second event space or the second event says that I should be able to get the numbers which are less than 3, right? Getting the number which are less than 3. And here the third event says that we want to get all those numbers which are greater than all those odd numbers which are greater than 1, right? So greater than 1 odd numbers, right? So there are only 2 possibilities, 3 and 5, right? Now I hope you know the union and intersection of the sets from the set theory. So if you get the union of these 3, E1, E2 and E3, you will be able to find out, if I write like E1 union E2 union E3, then you will be able to get 1, 2, 3, 4, 5, 6. All the elements are in here, right? If you see, then the union of all these 3 events, there are 3 different events, but when I took the union of all these events, then I found the entire sample space back. So such kind of events when when they are, they are, unionized. When we take the union of all those event spaces, then in that case, if they come back again to the sample space, then such kind of events, E1, E2 and E3, they all are known as the exhaustive events. These are known as the exhaustive events, right? So this is the, the other theory. This is the other definition related to one of the one of these type of events in the probability theory. And let me remind you again that these are not there just to remind by just to remember by heart all these definitions, but these have to be thought of. These are the pointers for you when you will work on the real life problems, that these are the scenarios which could come up, right? So we have discussed about the exhaustive events as well. Now let me tell you something about the random variable, right? What is the random variable? So considering the size of this video, I would not like to cover all the things in one video. I would like that you should be able to get few things in the in one video, so that it should not be boring for you. And in the next video, that's why we are going to discuss about the random variables, right? So the random variables I'm going to create just after this. Thank you.